Sampling techniques. Now let's go ahead and preview these techniques with an example. Start us off with an example, and then later we'll get into the student notes. Suppose an employee in a polling firm wishes to gauge the public attitude towards a specific public policy. Each member of the population could potentially have an opinion about the policy. However, it would be impossible from a time and expense standpoint to poll each member of the population. So for example, let's say a specific polling firm wanted to poll the city of Los Angeles. Well, in a town of, and even a greater metropolitan area of millions of people, it would be impossible from a, again, time and expense standpoint to poll every single person in Los Angeles. So there are methods we must kind of look at. So what we do instead of trying to ask every single person in Los Angeles, we would instead look for what's known as a sample. And in cases like these, where it would be pretty much impossible for a researcher to gather the data associated with the entire population, a subset of this population would be used instead as a representative. This subset is called a sample. Okay? Now, in order for this sample to be of optimal use to the researcher in making predictions about the population, the sample must be a good representative of the population. This simply means that measures associated with the sample would be very likely and closely approximate to that of the population. So that's where I'm going to talk about the sampling techniques in a minute, but kind of imagine this. Imagine if this polling firm wanted to ask maybe not everyone in Los Angeles, but they will just go ahead and choose a sample. Well, obviously they're going to want to be fair about the sort of folks they choose. Because clearly when it comes to public policy or any sort of law or any sort of political item, it's clear that some people on one side of Los Angeles, on one side of town, is going to think differently than other folks who live on the other side of town. So clearly there's going to have to be some sort of fair sample that will give us a good representation. Now, one thing is for sure, we're going to want to try to eliminate bias. Now, in order to achieve this close approximation, established sampling techniques are employed. These sampling techniques are designed to eliminate bias as much as possible. Now, information obtained from a statistical sample is said to be biased if the results from the sample are radically different from what the actual population believes. So the idea, again, is to eliminate bias and try to pick a good sample of people that will give us a good representation of what a population believes about a specific public policy in this case, or any other sort of a statistic we're trying to discover. Now let me give you an example of some bias. For instance, if a pre-election poll suggests that a particular candidate for public office will receive approximately 62% of the vote, but ultimately loses the election when his or her opponent receives more than 50% of the vote, then obviously the polling results contained bias. So again, you'll see this, in fact, almost every year you'll see some sort of polling that's like for some sort of upcoming vote. A big vote would be like the presidential election, but also any other local election or process, or even any proposition process will also have the same thing, where a polling firm will predict what a particular candidate's approximate vote will be. And again, this is an example of bias. So let's say this particular firm said that approximately 62% of the vote is going to go to him or her, but if his or her opposition received more than 50% of the vote, then obviously 62% is an impossibility, which means that the polling firm had some sort of bias, and they probably chose a poor sample. There could have been a number of reasons, which we'll get to momentarily. Now, there are 4 methods of sampling. In order to eliminate the bias, statisticians use 4 basic methods of sampling that are designed to ensure that each member of a population has an equal probability of being selected for the sample. These four techniques are one's called random sampling, systematic sampling, stratified sampling, and cluster sampling. And again, the idea is to eliminate bias, or at least as much as possible. Let us begin with random and systematic sampling. So starting with random sampling, a random sample is a sample in which each member of the population has an equal opportunity or equal probability of being selected. Now, here's an example of a random sample. Suppose an executive of a company that employs thousands of people all over the country would like to include her employees in shaping the vision for the future of the company. This would require a considerable amount of time and effort if you were to poll all these thousands of employees for each employee who is included in the process. Therefore, it would be impossible to include the population in this process. To actually poll all of her thousands of employees would be impossible. So what she does is she wishes for the opinions of the included employees to be representative of the entire company. So she decides that there should be 30 employees on the committee. Now, she needs to coordinate with human resources to create the database necessary to assign a unique number to each of her employees. And by each of her employees, I mean the thousands and thousands of employees. Then she uses a computer, which we'll show you later, to some sort of computer program to generate a list of 30 unique random numbers and uses those numbers to select the employees for the committee. Since the numbers were generated randomly, each employee certainly had an equal probability of being selected for the committee. This is an example of a random sample. Systematic sampling is where you obtain a sample by selecting every kth number of the population, where k is some sort of counting number. Okay? So as an example, suppose a bottling company would like to test the machines that are filling the bottles by selecting a sample of filled bottles and measuring the amount of product that the machine is putting into the bottles. The company statistician goes to the end of the bottling line and selects every 20th bottle and removes it for testing. This system is thus generated a systematic sample. Now here again, if it's a bottling company, then presumably this bottling company is producing thousands and thousands and thousands of bottles every day. And of course, it would be impossible and would be counterproductive towards, product and cost versus profit. It would be counterproductive for them to try to test or check every single bottle. So instead, the statistician chooses every 20th bottle to remove it for testing. This is known as a systematic sample. Another type of sampling, as I mentioned earlier, is known as a stratified sample. And it's obtained by dividing the population, very important, dividing the population into subgroups, or also known as strata, according to some characteristic relevant to the study. Then subjects are going to be selected from each subgroup. So we can go ahead and do an example of stratified sampling. So let's suppose a marketing executive is testing a product and measuring the sales potential within age groups. Opinions are gathered from people who fall into the following age groups. So we got the younger ones at 18 to 29. We got the sort of a little bit like maybe the career-oriented folks from 30 to 41. The middle-aged folks here, 42 to 53. And then we're getting people getting closer to retirement, and then obviously people that are retired and elderly folks. And then once they break up these folks into these subgroups, the data can then be used to determine the sales potential within each group. And what they'll probably do there, especially if each of these subgroups are big, is they can go ahead and perhaps do another like a random sample or a systematic sample within each subgroup. A cluster sample is obtained by dividing again the population, once again, but into sections or clusters, and then selecting one or more clusters and using all members in the clusters as the members of the sample. And this is important because, again, they'll be using all members of that cluster, of whatever cluster they choose. So an example of a cluster sample is, suppose the governor of a state would like to find out what the citizens think about a certain budgetary item that will require extra taxation. He is also concerned with the opinions of those who live in the western part of the state, the central part, and the eastern part. The governor will randomly select citizens from each part of the state to see if there are differences of opinion between the regions. And this is known as a cluster sample. And this will be, the clusters will be, once again, east, central, and west. Now let's go ahead and follow along with our student notes now that we got our preview out of the way. And again, as always, make sure you fill out the blanks and let me know if you have any questions. These will be helpful for quizzes and homework and of the like. Objective 5. Identify the 4 basic sampling techniques. Data can be used to describe situations or events. Data also can be collected in numerous ways. The most common is surveys, such as telephone surveys, mailed questionnaires, personal interviews, simple observation, or reviewing records. Researchers use these samples to collect data about variables from a large population. However, samples cannot be collected haphazardly because the data collected might be biased. And this is really what statistics is all about right here, is the fact that we are taking data from a sample based on a large population. Again, imagine trying to poll the million people and the million plus people that live in and around Los Angeles. It would be impossible to collect the data from everyone. So instead, we choose a sample, and hopefully a fair sample, that represents the entire population well and is not biased, or very, 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 very little bias. Now, to obtain unbiased samples, that is, samples that give each subject in the population an equally likely chance of being selected, statisticians use 4 basic methods of sampling: random, systematic, stratified, and cluster. And as always, I invite you to pause the video here and make sure you get these items written into your student notes. Now, random samples are selected by using chance methods or random numbers. So let's begin with our first type of sampling. Again, random sampling. Now, random sampling is a method that's associated with, let's say, numbered cards within the item of the population. And what you do is you kind of like mix the cards, like shuffle the cards, and then select the cards as needed. Another is to select numbers, such as like a lottery. If you guys mix the balls marked with possible numbers with forced air and select the one that rises to the top, that is a good example of just simply random sampling. Let's go ahead and do another example. In fact, I would ask you to go ahead and join me in this little example. If you wouldn't mind, please select a coin. Please pause the video, look for a coin, and I would actually like you to do this with me and record your results. And what you're going to do is you're going to flip the coin 10 times. And what I want you to do is record that you got either heads or tails for each flip. Okay? And as we do this, specifically, I want to ask, how many heads did you get? So I'm going to go ahead and flip this 10 times and see how many heads I get. So I'm going to go ahead and even tally and see what we have here. So let's go ahead and flip this coin here. I got tails for my first flip. Tails again for my second flip. Tails once again. Good day for tails, looks like, so far. Tails once again. Tails once again. Heads, finally. Tails once again. Heads. Two more flips. Tails once again. Finally, one more flip. Tails once again. Now I ended up with simply just two heads. And obviously you'll have to go ahead and fill in this answer here yourself for how many times you flipped the coin yourself. So please go ahead and flip your coin 10 times. And it will be a good practice to be doing these with me as long as I'm asking you to participate, because these things are going to pop up on tests and quizzes, and it's going to be good for you to practice these things alongside me. But go ahead and write in what you got, and the question I have for you is, were they the same? Now, because we flipped the coin 10 times, the answer I'm going to write in here is likely not the same. Flipping coins is an example of a random experiment or random sample. Now, large populations. Again, as I mentioned earlier, populations are often too large for the previous method. In fact, the previous method would take way too long using random sampling if we want to have large populations involved. So, random numbers are usually generated using a computer or calculator. For example, let's say there's a company you work for, and let's say they have an astonishing 9,863 employees, and your department needs a sample of employees for a study. Obviously, they're not going to have time or money to go ahead and talk to all these students. Okay, employees, which could be students, but you have determined that you need at least a sample of 842 subjects. Now, 842 subjects, that's quite a lot of people. Lots and lots of people, like 842, and even 842 is going to take you a long time to figure out. So, but certainly we can all agree that 842 is much less than 9,863. So what we're going to do is we're going to go ahead and choose a sample of 842 employees using numbers between 1 and 9,863 without repetition. And we're going to do this using a computer generator from a program or what have you. And I'll show you in a little bit how to do that with your TI-81, or excuse me, your TI-84. Okay. And then the employees associated with the selected numbers would be in the actual sample. And what the sample is going to be for remains to be seen, but this is an example of why you want using just simply random, like for example, let's say we put all these 9,863 folks. Let's say we put all their names on a piece of paper and threw it into a hat or a big bucket. Selecting 842 names out of the hat would be a very time-consuming and probably not very profitable use of time. And so again, a computer generator is much more efficient, a lot quicker, as you'll see in a moment. Now I'll come back to this one in a moment, but before we do this one, I'm going to go ahead and show you how to generate random numbers on your calculator. So let's say I wanted to generate 10 random numbers between 1 and 85 on my calculator. Now at this time, I would ask you to please have your TI-84 out because right now, I know a lot of you can see the buttons I push, and maybe you might even think to yourself, oh, I get it, I can see what he did. But nothing beats you actually doing the process alongside me, and this is one of many important processes you'll be going through in this class. So once again, please pull out your TI-84. I believe most TI-83s will work as well. And please remember that if you don't have access to one currently, you do need to get access to one as soon as possible. They are required for this class. And what we're going to do is we're going to go ahead and start by clicking this button here where it says Math. The Math button here, if I click that, takes me to this page here. And as I have this page here, you'll notice I have several choices here. And what you can do is you can go ahead and click the right key to the right, or the left key to move all the choices to the left. You're kind of going left and right with those little tabs there. But again, once again, how did I get here? I clicked the Math button. Okay. And then what we're going to do is we're going to go ahead and click to the right until we get to PROB, which stands for probability. And remember, what we're trying to do here is we're trying to randomly select 10 numbers, but the numbers must be from 1 to 85. And you can see I have a lot of these RAND words here. That does mean random. And specifically, I want to go down here to number 5, which is random integer. And we'll go ahead and click enter. And the smallest number I will actually pick is 1. The largest number I want to pick is, again, 85. We're going from 1 to 85. And what I want to do is the n is how many numbers I want. I will be choosing 10 numbers. And then you go down here to where it says paste. And the reason why it says paste is because once I click enter, you'll notice that it pastes this information here. Okay. And I'll click enter in a moment, but before I do, notice how I can go ahead and click to the left a few times. And I can actually even go ahead and delete some of this stuff. What some of you might notice is that some of your calculators does not give you the ability to copy and paste items. In fact, once you click that number 5 and get random integer, like I have here, many of you might have a situation where you click that random integer number and you actually end up with this information right here. It just basically says rand int and then an open parentheses. If you have one of those calculators, again, what you do is you just type the smallest number, comma, and here's the comma right here. So 1, comma, then the largest number. The second number represents the range of numbers which you'll go up to. First number represents the lower range. The second number represents the upper range. And then I do a comma again, and I type the number 10, and that represents how many numbers you want. Close parentheses, click enter. And there are my 10 random numbers generated by my calculator here. And you might be wondering, well, I see, let's see, we have 1, 2, we have 81, 78, 13, 44. Yes, these are all between 1 and 85. But I only see 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Well, whenever this little arrow is popping up here, you can go ahead and just start clicking to the right, and it'll give you all 10 numbers. Click left and right, you can see all 10. Okay. Now, let me go through the process one more time, but this time, let's go back to that previous example where let's say a company for which you work has 9,863 employees, and you need a sample of 842 employees. Well, I believe this calculator can handle that. Let's find out. Again, click Math, scroll to the right under Probability, go down to number 5. You can either scroll down to number 5 or literally just click the number 5 here. We're going to go ahead and number our employees from 1 to 9,863. The number of employees that I need to sample are 842. We will either paste it like this calculator lets us do, or you'll literally just type in the numbers as you can see here. We click enter. Now this one took a little longer. If you noticed, it took longer for the calculator to think, but we were able to do it. And you have here these numbers. I'm scrolling through to the right. There are 842 random numbers that were chosen. Now it would be pretty difficult to have to write all those numbers out, but at least you have something given to you fairly quickly, definitely quicker than drawing numbers out of a hat or even just performing some sort of lottery. Calculators and computers can do this for you. Once again, our example is asking us to find 10 numbers between 1 and 85. And then we use the right arrow on the calculator to see if the rest of the randomly selected numbers, if any, occur more than once. Repeat the procedure to generate as many more randomly selected values as you need. So one of the problems with the randomly selected integers on this particular calculator is that sometimes your numbers do repeat. And in some situations, you don't want them to repeat. Now, historically, before computers were available, random numbers were actually selected using tables. So why don't we go ahead and use the random number table on the next slide and in your handout to select 10 subjects from a population of 85 items. So this example is actually asking for the same exact sort of answer as the last example, but this time we're going to go ahead and use a table. Now, what I suggest we do is go ahead and put your finger on this table somewhere randomly. I'll use my laser pointer here and just kind of, close your eyes. And what you're going to do is you're going to go ahead and place your finger on this thing and go anywhere on this table, anywhere at all. Okay. And the moment you stop your finger, you're going to start with that number as your first random number and go down 10 numbers from there. So I'm going to count to 5. And when I count to 5, I'm going to go ahead and stop and put my, whatever number is closest to my finger, I'm going to go ahead and start there. So here we go. Ready? 1, 2, 3, 4, 5. So it looks like I'm closest to the number 28. Okay. And from here, again, we're picking 10 numbers, right? So I'm going to go from the 28 and then I'm going to go down from there. Okay. So my random numbers just so happen to be 28, 69, 73, 53, 44, 85, 43, 15. Now you'll notice I want 10 numbers, right? So far I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. And 1, 2, 3, 4, 5, 6, 7, 8. I got down to the bottom of my column. And I'm going to continue by going up to the top of the next column. So 93 and 13. And these here would be my 10 random numbers for this particular sample of 85 numbers. So a bit more clunky than the calculator, but it still works. Now, beyond random sampling, we have something known as systematic sampling. Systematic samples are random samples obtained by numbering each subject of the population and choosing every kth subject. The first subject is selected by randomly choosing a number between 1 and k. Then, after that, you go ahead and select every kth subject in the list to complete your sample. Now, systematic sampling definitely has an advantage of selecting subjects throughout an ordered population. This sample is fast and convenient, but only if the population can be easily numbered. Now suppose there is a list of 350 subjects and a sample of 35 is needed. Now let's say that 350 divided by 35 is 10, so that each group includes 10 subjects. So in this particular case, our K will be 10. So we're going to go ahead and use our calculator to randomly select a number between 1 and 10. So I'm going to go ahead and use that same, I'll go ahead and you'll hear me clicking here. I'm going to go ahead and use that same program I used a moment ago. So again, I'm going to click the math button, click probability, go down to item 5, at least it's item 5 for mine. My lower limit's 1, my upper limit will be 10, and I'm only looking for one number. So you'll type in 1, 10, 1. We're only looking for one number. In which case we end up with, I got 7 for mine. You can go ahead and fill in whatever one you got. Okay, this is our first subject selected. Now the sample includes the first 7 and each one of the following by adding 10. And now we need to do this 35 times because again we need a sample size of 35. So if I was to list my systematic sample, it would look like this. It'd be 7, 17, 27, 37, dot, dot, dot. And we have to go all the way up to, but obviously not including 350, but you'll get up as high as 347, and then you'll have your 35 subjects. Now, please pause the video, try this yourself, and I'd say the critical would be allowing your calculator to randomly select a number between 1 and 10, and then go from there. And compare your sample with my sample. Now, stratified samples are slightly different than systematic. They are obtained by dividing the population into groups according to some sort of characteristic or attribute that's important to the study. Previously, you saw me talk about this when I was talking about age groups. Now, a random sample is going to be taken from each group once these are stratified. So here's an example. A marketing firm samples a population by income level. The population is separated into 3 income categories: lower income, middle income, and upper income. Those are the strata. The marketing firm selects some subjects from the lower income group, some subjects from the middle income group, and some subjects from the upper income group. Cluster sampling. To select a cluster sample, the population is also divided into groups, but these groups this time are generally intact or some sort of geographic group. So by intact, it could mean like a family, like a household, or geographic group, meaning we choose a sample strictly from one certain part of Los Angeles or one certain part of whatever town you're in. But once the groups are determined, a few of the groups are randomly selected within these clusters, and then everyone in the clusters are chosen to become subjects. So, for example, a school district wants to survey the opinions of elementary school students. So what they do is, the clusters are the intact classes for each elementary school. Several clusters/classrooms are randomly selected. And once those are selected, all of the students in each of the classes, again, these are the clusters here, are going to become a part of the sample. So you can imagine that once they establish which classrooms will be taking the survey, they will give that survey to each and every single student within that specific classroom. Now here are a couple notes on stratified, versus clustered. And the main difference between stratified sampling and cluster sampling is that although in both types of sampling, the population is divided into groups for both, the subjects in the groups for stratified sampling are more or less homogeneous, which means that they have similar characteristics. For example, let's talk about age groups. One of the strata could be people from the ages of 18 to 29. While the subjects in the clusters form more what are known as like miniature populations. Again, for example, a miniature population could be one specific classroom from a specific elementary school. And so the point is that for clusters, they'll vary more in characteristics. So, and that does have its advantages, but it also has its disadvantages, and you'll have to decide between stratified or clusters would be best for a specific experiment. Now, some more notes on stratified versus cluster. For example, let's say a researcher wanted to use the freshman class at a university as the population. Again, if it's a large university, then the freshman class is going to be it's still going to be a large population, so it'd be impossible to ask every single freshman. Now, he or she might use a class of students in a freshman orientation as a cluster sample. So you just simply take one of the classes from that freshman orientation. Okay. Now, if the researcher were to use a stratified sample, you would need to divide the students of the freshman class into groups according to their major, gender, age, etc. So hopefully this example shows you the true difference between stratified versus cluster. Now also, cluster samples save the researcher time and money, for sure. But unfortunately, the researcher must be aware that sometimes a cluster does not represent the entire population. So you must be very careful when using cluster samples, even though, yes, they do save a lot of time and money. Now, there are other sorts of sampling, but the following sampling here, for this one, in this case, this actually can potentially create a bias and can cause us problems. So the next type of sampling, which actually can be problematic, you notice I did not mention this in the previous methods of sampling, because again, it's very problematic. Convenience samples are samples that consist of subjects that are available or easy to find. Like imagine trying to do a survey of only people that happen to be walking past your front door of your house or your apartment. Okay, well, chances are that's not going to be a very accurate sample because it probably doesn't represent, for example, the entire city that you live in, because maybe you live on one certain part of the town versus another. But the point is that the sample is certainly not random. Okay, and the population is unknown, and the selection of subjects is haphazard. The results end up being biased or flawed. So this type of sampling is best for pilot studies. Like let's say if you're just trying to, you're just trying to basically get something off the ground, then maybe an initial convenience sampling would be fine. But again, the results do usually end up becoming very biased. Now, whether it's convenience sampling or any other kind of sampling, random sampling, stratified sampling, any sampling, there is a possibility of what's known as sampling error. And I talked about this earlier, where what if the politician running for re-election, the poll says that this person will earn 62% of the vote in a poll before the vote, but then when the actual voting took place, the opponent got over 50% of the vote, which means that there was some sort of error. So samples are not perfect in most cases. They're not perfect representatives of the populations from which they're selected, Therefore, there's always some sort of difference in the results. Again, the politicians' poll numbers versus the politicians' actual receiving of the actual votes. Now, other errors that exist in samples occur for other reasons. But this is going to be something that you have to be aware of when it comes to statistics. Let's first talk about the definition. Sampling error is the difference between the results obtained from a sample and the results obtained from the population from which the sample is selected. For example, a sample of full-time students indicates that 56% of the student body is female. However, the admissions office, the people that actually store the actual data, states that of all full-time students, 54% are female as opposed to 56. So this would indicate a difference of 2% due to sampling error. So imagine you're out on the campus and you're trying to survey all the students that you can. By the way, to know which students are female, you need to know also which ones are male. So if 56%, according to your survey, are female, and then you compare it to the actual admissions office, who has all these students' information on hand, you can see in this case you get a 2% sampling error. Now there's also other things known as non-sampling errors, which we'll get to more in a moment. But non-sampling errors occur when the data are obtained erroneously, okay? Or the sample is biased or non-representative. Certainly, you got to be very careful when it comes to statistics. Many times people will believe what they want to believe based on their own personal preferences. And in those cases, you can potentially get a non-sampling error, especially if someone who is extremely biased is running the survey or trying to run the experiment. So an example, for example, of a non-sampling error, let's say we have a researcher that interviews subjects who enter the mall through a particular entrance to determine the reason for their visit. Okay, this sample is most likely not representative of the general customers for several reasons. Okay, for example, the sample was likely taken at a specific time of the day when not all customers up to the mall were shopping. And for example, there might be people that were, at work that went to the mall later, or there might be people walking through that entrance that maybe have kids and only come during certain times. And obviously, people who have kids, parents, probably think a little bit differently than folks who do not have kids, for example. Also, the sample was taken at a particular entrance through which all customers do not enter. There are other entrances, presumably, to this mall. Therefore, all customers to the mall, the ones that entered the other side of the mall, did not have an equal chance of being selected. So the difference between the sample and the population in this case is due to a non-sampling error.